Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey, Houston, we don't have a problem. Hey, physics, today I want to talk about vectors, and specifically, we talked briefly in the last video about vectors, but let's specifically talk about this. As we said in the last video, vectors have magnitude. Remember, that's just a number, and they have direction. All right? But we also want to contrast that with something called a scalar. So vectors have magnitude and direction. Scalars only have magnitude. So a vector, velocity is a vector. So example would be, as we said, like 1.5 meters per second at 10 degrees north of east. So if we're thinking about that, well, how would I draw that? We draw a coordinate plane. We would say we would do 1.5 meters per second, and I would go 10 degrees. So north of east, if this is east and this is north, you're north of east 10 degrees. So this is 10 degrees, and this is 1.5 meters per second. So that would be an example of a velocity vector. You can also have a distance vector, and a distance vector, let's go this way, let's say, boom. And let's say that this is x and this is y, where this was, this is going to be just, let's just say we're at -3, 2 over here, right? Let's say that's 10 degrees. I don't know if that's at 10 degrees. And so it's the same one. Let's say this is 1.5 meters, but it's 1.5 meters, not 1.5. Actually, it's not 1.5. What is it? 3.6. So let's do that one. You can also have a distance vector. With a distance vector, let's do something here where we're going to go like in this direction. So this is just x and y. All right, and I'm going to go boom like this. And what I've got here is, let's say that I have this at 10 degrees, something like that, and that this is, 30 meters long. Okay, then what you would say for a distance vector, we would say d arrow, sometimes x arrow, same idea. Well, it's not the x, because it's x and y, so it would be d arrow, would be equal to 30 meters at 10 degrees. So if this is north and this is west, it's 10 degrees north of west, because it's above the west, north of west. Now, a scalar only has magnitude, so to contrast here, if a scalar has magnitude, it's just if I just say 20 meters. I don't specify a direction. Or I say, 1.5 meters per second. Now, 20 meters is distance, and 1.5 meters per second is speed, because we do not have a direction. So the difference between vectors and scalars is speed. And then the last thing we want to talk about in this video is that when we have a vector, what we often do is we break it down into its components. This is called component stuff. So if I've got, again, a coordinate plane, and I've got this right here, let's say this is a 20-degree angle, and let's say it's a velocity vector, so v equals 25 meters per second. Because, so that somebody's, a ball's being shot off at an angle of 20 degrees, I want to figure out, we want to break it down into its components. So it's going up at an angle of 20, but if you think about it, we want to break it down into its x direction. So we would say v arrow x. So it's traveling here, right? And then here, also, it's going up, v arrow y. But we want to figure out what those numbers are, so we have to use trigonometry to do that, so katoa. So, let's do x. This is the adjacent, and this is, so I know the hypotenuse is 25, and the adjacent angle, or the adjacent number, we want to figure out. So adjacent, so, I always break it, ka, it's so and ka. So adjacent, so this is cosine. So I would say Vx equals, well, let's just do it. Let's write this. So cosine of 20 degrees equals adjacent Vx arrow over, we know this, is 25. So I get my trusty calculator here, and I'm just going to type in cosine of 20. Now, one thing important that you need to make sure you do is make sure that your calculator is set to the degrees mode. And when I do the math here, you just take cosine 20 divide by, or times by 25, because it's like cross multiply. This times this equals this times Vx times 1. And then that gives me 23.5 meters per second. So that's the x component, right? In the x direction, this is 23.5. To do the y, it's the same ballgame. You would say Vy is going to be, I would use the equation sine of 20 equals Vy over 25. So I'm just going to type in sine of 20 on my calculator times 25, and I get this to be 8.6 meters per second. So Vy is 8.6 meters per second. If I say y, I'm specifying a direction. Does that make sense? It means just up, right? And if I say Vx, I'm saying the direction. It's going to the right. So it's important that we can break it down via the components. You'll find this out is super important when we're like trying to figure out when we shoot up a ball, where it lands, et cetera, et cetera. So yeah, hey Houston, we don't have a problem.